Right, guys, welcome to the live stream. So I hope I'm not the only one here with N5s. There are very few people with N5. So I hope you guys are here. If it so happen that we don't have people here, just know that some people, they were informed that we're gonna start the stream at 7:30, but we got disturbed by the way. Yeah, I got some disturbance, so I had to postpone it. But I did send the link earlier on, I think 30 minutes before we start. So anyway, guys, welcome. I only see 3 people on this live stream. I assume they're gonna join along the way. Share the link with your friends, guys, because we already started. So this is for N5, N3. As you can see, there is an QR code there. Just in case you're not part of the channel, you can scan on that QR code, people, and you can able to share some information via WhatsApp concerning N5 question papers, videos, and also some other stuff concerning mathematics, right? So I'm gonna go and to the question that we're supposed to solve there. So I took this question paper that you see here. This is a 2019 July paper, guys, for mathematics N5. So on this video, we're gonna focus on question 4, which is integration. I've noticed most people are struggling with integration. So we're gonna focus on integration. Then maybe tomorrow, if we do have numbers, we're gonna do other other integration, by the way. So you can do a live chat, guys. If you don't understand, we have only an hour because the mic that I'm using can last only for an hour. After an hour, I switch it off, it switches off, and I have to recharge it, and that can be sometimes annoying, so it can inconvenience us. All right, people, let's start. Whoever is not here, they're gonna start the stream at the beginning. They will able to watch it from the beginning till the end, because I'm gonna also leave this as a video. All right, so there's only 5 of you guys there. We just gonna do it. So I'm gonna scroll down. If you do have this paper, go and download the paper, guys. Right, if you don't have the paper, go and download it. So we're gonna do this question 4 here. It's all about integration, guys. Let's look at this question 4. I hope it's visible, guys. Let me just zoom again. All right, let's zoom again. Yes, this is our question 4. So we have the following questions, which is 4.1.1, 4.1.2, 4.1.3, 4.4, and so on and so on, guys, right? So we're gonna do them all together one by one. So I'm gonna start with question 4.1. I'm gonna write it on the side. I'm gonna help you guys identify what is it, and then we're gonna try to integrate it, right? So let me just write it on the side, and then we integrate it. Let me just zoom down there. Right, guys, you can comment there if you can hear me. I hope you can hear me. Please comment whether you can hear me or not. Right, there's only a few of us here, so it's not looking good, but don't you worry, guys, we're gonna be fine. People, they're gonna join us. If you're doing any other level, this is for N4s, guys. This is for N5. You can exit the stream. This is for N5. So we have, this is basically, this is how it looks like. We have 4, right? And then we have 1 over x minus e to the power of negative x, right? And then we have cos, right? Let me just create another space again, create another space. Then we have open bracket, we have e to the power of negative x. Then we have plus natural log x. So if we close this, it's gonna be dx, like that. Basically, this is the question for 4.1.1. I'm just gonna write it on top here, 4.1.1. All right, I hope everyone can see that. All right, let's continue, guys. Let's continue. If you know someone who's doing N5, alert them that we are busy with integration here, guys, right? So I hope they will be able to see it. All right, so let's continue here. So let's look at this, guys. We are here. Oh, thank you, my Josie. I can see your comment. All right, let's hope others are here as well. Because with N4s, guys, I have close to 200 people watching, but I understand because the videos were promoted. So this is 4.1.4. Guys, let's start here. First of all, you need to recognize which of these is the f of x then. Now, if I can highlight this one here, let me highlight this very quickly. This here is our f of x, guys, right? And then that there, inside the bracket there, is our f of x prime, right? So we have these types here where we can say, when we can integrate the following: f of x, the power of n, multiplied by f of x prime, right? Dx, right? And also we can use substitution here, guys. So I think it's best for us to use substitution, because this one here can cause a lot of confusion. This one here, the first type them, right? So let me just erase it very quickly, because you're not going to use it. So if you use substitution though, again with substitution, you must be able to notice which of the two it's f of x. Like I said, what is inside there, the cos, it's f of x, e to the power of negative x plus ln x, that is f of x. So if you can say u is equaling to e to the power of negative x plus ln x, right? Now this here, you can see that f of x prime is this one here, as you can see there, is this one here. Because if we derive this here, we derive du over dx, right? We know that the derivative of e, guys, is going to be negative e to the power of negative e plus, and then the derivative of ln or natural log is actually 1 over x. There we go. Right, guys? So as you can see, look at this. Let me rearrange it. If I do rearrangement here, we have 1 over x, right, minus e to the power of negative x. If I rearrange this one here, guys, let me just use a black color. If I rearrange this, which is that one, it kind of looks like this one here. You guys see, we have 1 over x minus e to the power of negative x. That is the same then. So we can continue and make du subject of the formula. As you can see there, we have du over dx. If we make du subject formula, we say du, right? And then we do some cross multiplication. Can you put this inside the bracket? 1 over x minus e to the power of negative x. If you cross multiply there, we're going to have dx like that. It means we just cross multiply this dx there, guys, right? Remember, we have the equaling sign here. We did some cross multiplication. So this is du, which is equaling to 1 over x minus e to the power of negative x, right? So this is our du. So if we decide to use the u method, let me try to use it. We can see, look, let me just use a different color again to highlight this. We have dx there. We also have this inside the bracket, which we have 1 over x minus e to the power of negative 1. We also have it here as well. Do you guys see? We have 1 over x minus e to the power of negative 1 dx. So these two, when you check, they are equaling to du. Do you guys see? They are equaling to du. So we can write it as du, right? Then we have what here? We have this cos here. Remember, this is equaling to u. So we can say cos u, right? Let me just use that. I hope you guys can understand. Cos u. But we have the coefficient here, which is our 4 there. You guys see the coefficient of 4. So we can write it as a 4 like that. You guys see? Now, in this case now, we are actually integrating 4 cos u du, right? I'm very, very concerned that people can able to see this. I hope you can able to see this part here, right? Is the same as, let me highlight this with colors, the same as this multiplied by that, right? So I hope you can able to see that, because if you can't see that, well, this can be a bit confusing, and I don't have a lot of people, so I hope you guys can comment there. If you don't understand, please comment so that I can help you to understand this better, right? So when you integrate this, now we know that the integral of the trig, I'm gonna use the one that we have there, it's obviously going to give you cos, then we have k, right, nx, okay, dx. When you integrate this, guys, first of all, cos becomes positive sign, so it's going to be k sine, right, and then nx divided by n. Guys, do not forget this n here, this n, which is the coefficient of x, you must divide by it here, and also you must keep it as much as we derive these two here, cos and sine, right? So if we use this formula there, let's use it. We're going to say y is equaling to, right, we have 4 as our coefficient, or as a k, so we can say 4, right? And then we say sine, and then what is our u? Our u here is just oh, the coefficient of u is just u. Yeah, very simple, u, right? And then plus c. There we go. So our final answer, this is going to be y is equaling to 4 sine. Instead of writing this u here, remember u is equaling to all of that, so we're going to write e to the power of negative x plus natural log x plus c. There we go. So this is how you do this one, guys. I hope you manage to get it, right? It was not that difficult, to be honest with you guys. It was just straightforward, as long as you can see how to substitute du there, because this is the whole of this, it's actually du multiplied by, in fact, du, it's open bracket 1 over x minus e to the power of negative x close bracket multiplied by dx, right? So this is how you do the first one there. I hope people manage to get this or can understand this. Just in case you didn't understand, you can comment there on the comment section, and then let's see if I can able to help you. But if you are fine, you can I'm gonna erase this, guys. I'm gonna erase this. Where are the people? Where are the people? People are not around, so I'm meaning we want to finish this one within 30 minutes. I'm sure we're gonna finish this question paper within 30 minutes. Okay, so let's look at number 4.1.2. If you guys don't have questions, I am moving on, right? So you're gonna ask me offline whenever we are not live, because we don't have enough people online. We only have very few people, which is 7, 10. It jumps from 7 to 10. So yeah, that's what's happening there. So let's look at 4.1.2. There we go. So 4.1.2, we have this here. We have 1 over root of 4, right, minus 9x squared. There we go. Right, let me just create more space here so that we can solve this one. Guys, this one here, the minute you start to see something of this sort, where you have 1 over and the root, and you have x squared here, mostly when you have x squared, chances are this is a substitution. I know you can mistake this for the first type. It is not the first type, guys. This is basically the substitution. So there is a formula for substitution. Let me try to find it so that I can show you which formula we're going to use here. So in your formula sheet, though, that formula, it doesn't show, guys. It doesn't show exactly how I'm about to show you guys. So bear with me. I'm still looking for that formula that you just need to substitute. You just need to substitute the values there, and then that's it. You finished. It's really not that difficult, people. Right, let me just go straight to the formula. So here we have this formula here where they say if you are given sigma, right, and then you have dx over, just do this, um a squared, right, minus b squared multiplied by x squared, right, and then this is going to be equaling to 1 over b arc sine, and then we have bx over a plus c. Guys, this is the formula that I'm talking about. On your formula sheet, what is missing there? You do have it, by the way. What is missing is a beam. Your formula sheet does not have a beam. So whenever you are writing your test or your exam, make sure that you include B on your formula sheet before you start writing. So this is basically what is happening there. So how are we going to solve this one, my good people? How are we going to solve this one? Guys, comment if you're still able to understand there. There's only one comment there by my Josie. Yeah, or people went out for the weekend. Probably people went out for the weekend. Yes. Right, let's solve this. They will watch this offline. All right, so let's look at a. Look, a squared is the same as 4 there when you substitute. So we can say a squared is 4, right? And then let's look at b. B is a coefficient of x squared. So we can say b squared, right? B squared is a coefficient of x squared. It's the same as 9, right? So we can say when you square root these, we can say a is equaling to 2 and b is equaling to 3. You guys see? Now, all you have to do here to integrate this one, guys, is just to substitute the values there, and then we get our answer. So your final answer is going to be y is equaling to, now we have 1 over b. So 1 over b, our b is 3 there. Arc sine, right? And then inside the bracket there, we have bx over a. So b is 3x over a, which is 2 plus c. That is your final answer, guys. I hope you guys can able to see. Someone asked a question. Someone asked if I have the textbook with me. Not really. I don't have it. It's a bit far, Masugu. But you can. Why do you want the textbook? Which textbook? The one from N5, right? What is it that you wanted from the textbook? Maybe we can tempt it. So let's continue here, guys. This is the final answer, guys. Simple, straightforward. Make sure that when you come across this type of a question, especially when you have something of this sort, when you have the the numerator of 1 and you have x squared here, just know that you need to use substitution most of the time, right? So make sure that you double check, and when you go to your formula sheet, which is there, you don't have b there. Okay, the b is missing. Let me check if I can able to show you the formula sheet. If we can show you the formula sheet, let's check if we do have, oh, we do have the formula sheet here next to me. So let me just go to the formula sheet and let's check exactly where is it. Guys, you have to be careful, guys. These are free marks, by the way. These are free marks. So here it is. Let me just zoom very quickly. Guys, look at this. Look at this. You see, this is what is given to us here. You see this here, b is missing here, and also 1 over b is missing there. So guys, make sure that you include the b, the coefficient of x there. On your formula sheet, it is missing, right? So let me just go back to the questions, right? I hope you guys understand, though. If you don't understand, ask questions there on the formula sheet, guys. Ask the questions, right? So let me erase this very quickly. While I'm erasing, let me read the comments. Now, someone says something. There's a problem I want, oh, by parts problem want us to solve, right? Can I finish what I'm doing here? Then we're gonna try to solve that question, Masuku. All right, we're gonna try to solve that question. So let me just do these questions here. Please remind me before we finish. All right, let's look at 4.1.3. Right. So 4.1.3, guys, it's very right. It's not difficult, but most people are struggling to use the long division. This is our 4.1.3. I hope you can see. Just zoom it one more time. Let me just zoom it one more time. Okay, there we go. This is this is the one that we will be doing now. So we're gonna have to use a long division. So how do you know that you're supposed to use long division here? When you have improper fractions, guys, right? This means that when you have the numerator with the highest power compared to the denominator, as you can see, our numerator here, it has x to the power of 3 plus x, and then our denominator only has x to the power of 1. So the numerator has the highest power. So this here, it will, that's why you know that you need to use long division when you integrate this one. So I will also gonna write it on the side so that we can able to solve it. All right, let me just go to the next. Let me just write it here. 4.1.3. There we go. So let's do it. So this is what you're gonna have. You have x to the power of 3 plus x divided by x minus 1 dx. There we go, guys. There we go. So I'm just gonna create more space here, guys. I hope you can see, people. I hope you can see. All right. Let me do this. So when it's like this, first thing first, you have to use the long division method. So I'm just gonna do this, but you can use other methods, guys. They are allowed as long as you understand the other method. So the divider, we put it here, which is gonna be x minus 1, and then the one that is being divided, we're gonna put it here, which is x cubed. Try to make it look visible. X cubed plus x. There we go. Now, as you can see, we don't have x squared there, guys. So I hope you will be paying attention, because this method, a lot of people don't like it, but it works, guys, right? The other methods, they kind of give you a challenge when you have this type of terms. Look at the numerator. We have x to the power of 3 plus x only, and usually it's x to the power of 3 plus x to the power of 2 and x to the power of 1 plus constant, right? So this time around we only have x to the power of 3 and jump straight to the x to the power of 1. So how do we actually do this one? The first step, I'm gonna do step by step. Step number 1, you divide, right? Divide. How do you divide this x cubed, right? X cubed divided by x. This x cubed divided by x, right? When you divide x cubed by x, you're going to have x squared there, right? So your answer, remember, this is going to give us x squared. So this answer, you write it there on top, guys, right? Right, let me just erase there. Step number 2. Oh, what happened? Step number 2. Let me erase there so that I can write step number 2. Let me just leave it like this. Step number 2 is to step number 2. Step number 2, you multiply, guys, right? Multi, right? What do you do here? You're going to multiply this x squared with x minus 1. So this x squared there, you multiply with everything there, right? So let's do it. So if you say x squared multiplied by x, this is going to give you x cubed. There we go. And then if you say x squared multiplied by negative x, negative 1, I mean, it's going to give us negative x squared. There we go. So that is step 2. Step 3. It's time for us to go to step 3. We multiply our answer for division. This one here. We multiply this, all of this that we just got there, right? We multiply by negative 1. So you can say multiply x cubed minus x squared by negative 1. So we multiply by negative 1. There we go. Then we underline there. Now, step 4, which is the last step of the long division method. What you do here, guys, is when you multiply, you will add or subtract, right? Depending on what you get there. So let's look at this. If you multiply this -1 with x to the power of 3, you're going to have negative x to the power of 3 here. So this x to the power of 3 will cancel with this x to the power of 3. Then we have 0, right? If you multiply this negative with this negative x squared, you'll have positive x squared. So you're going to write it as positive x squared. It does not add with anything because we do not have x squared there. So you're just going to drop it. You guys see, right? Now, if there were x squared there, we're going to multiply or add. And then this x there is going to come here as well because it has nothing. We're just going to drop it and it becomes x. Now, we repeat the steps again. The first step, let's look at the first step. The first step this time around, we divide. The first step this time around, let me just erase these things. We divide x squared with, there we go. We divide x squared with x, right? So this x squared here, we're going to divide it with that x. Remember, the x is the divider. So x squared divided by x, you're going to have positive x. There we go. Then the second step, what do we do now? Instead of the second step, instead of multiplying x squared, right, we multiply by x. This x here is going to multiply everything there. So it's going to be x this time around. You guys see? I hope you guys can see because things can get really, really tough. So when you multiply, what do you get then? We're going to have x multiplied by x. See, let me just erase this very quickly so that you can able to see. We're going to have this x multiplied by that x, right? So what are we going to get there, guys? We're going to get x squared. There we go, x squared. You write it underneath them. And then we're going to have, again, we're going to have -1, right? We're going to have -1 multiplied by that x. So we're going to have negative x. So we're going to have negative x like that. There we go. Then that is step 2. Step 3, we are here now. We multiply these by -1. So let's do it. Instead of what is this? What is happening? Oh, instead of because here this was from the first step. Instead of having x cubed this time around, what do we have there? We have x squared minus x. We multiply by -1. This step here. So let's do it. So you multiply by -1 there, and then you divide. So if you multiply multiply by x squared, this becomes negative. So x squared divided minus x squared is going to give you 0. And then we're going to have this one here, negative and negative. When they multiply, they're going to give you positive. So you're going to have x plus x. They're going to give you how many x's? They're going to give you 2 x's. Oh, by the way, this is plus 0, right? There we go. And then we continue. We don't have anything that will drop there. We're just going to continue. We repeat the steps again. This time around, I'm not going to show you guys, but basically what we do, this x2 is going to be divided by the x there. So when you divide x2 with x, you're going to have plus 2. There we go. Now, from there, step number 2, we multiply. In this time around, we don't multiply x, we multiply 2. Just go there. We multiply this 2 with everything there. You guys see here? There we go. So we multiply that 2 with everything there, guys. Right? I'm teaching you the long division, by the way, so you need to learn it. So if you multiply that 2 with everything there, we're going to have 2x, right? Because we're going to say 2 multiplied by, we're going to say 2 multiplied by x, we have 2x, and we say 2 multiplied by -1, we have -2, so minus 2. Then we do what? We underline there. And let us not forget, we need to do the third step where we multiply this by -1. So if you multiply the whole of this by -1, this 2x is going to be negative, which is going to subtract with this one there. So this is going to give us 0, right? But look, we have -1 there, we have -2. When they multiply, they're going to give us plus 2. There we go, guys. Then from there, this here is our remainder. Hey, I hope you guys managed to understand this, because hey, it can be challenging. Right? Since we don't have a lot of commenters, I assume that everyone understood. Right, I'm erasing these steps, guys. If you want to watch them again, you just go back to the video and rewatch. So what do you write here, guys? What do you write? Here's what you write. So you're going to write sigma. Then all this, you're going to write it there. You're going to have x squared plus x plus 2, right? This 2 there. But let's not forget, we have this 2 as a remainder. We say plus 2. But the remainder, you always divide it by our divider, which is x minus 1. Remember this x minus 1 there is the one that we divide by it. So dx, right? Right. So I'm also erasing this space. I need it, guys. I need it. I need it. I need it. All right. So let's start integrating. So when we integrate, let's go back. Let's use the right color. Let's be consistent with our color. That when we integrate, let's look at the first term, x squared. We know that x squared 2 plus 1 divided by 2 plus 1, right? Plus we have this one, the second term, which is x, which is 1 plus 1 divided by 1 plus 1, right? And then we have the third term, which is 2. It's going to be 2x. And then the fourth term, this one here, we're going to use this type, guys. We have this type here where we say we have f of x, I mean dx, and then we have f of x, right? Right. Oh, let me go back, guys. I made a mistake. It's actually f of x prime. It's f of x prime over f of x. There we go. There we go. So when we have this, the integral there is gonna be y. It's gonna be y, then ln, then x, basically. So when you look at that question here, when you look at this one here, our f of x, the derivative of f of x, for our f of x, this is supposed to be like this, 1 over x plus 1, because our f of x here is 1 minus 1. So f of x prime is going to be 1. But we don't have 1 there, we have 2, right? So if you multiply there, we're going to be having that 2 there. So you can say plus 2, then you say ln x plus, oh, not x, ln x minus 1 plus c. So this here, guys, it's our integral, right? So you have to fix it. Obviously, don't leave it like that. So we're gonna have x to the power of 3 divided by 3 plus x to the power of 2 divided by 2 plus 2x plus 2. Let me just create space, guys, because I'm starting to write in a skew, what is this, a skew line. Let me go back. Yes, yeah, there we go. Plus 2 ln x minus ln x minus 1 plus c. This is our final answer, guys. Right, I hope everyone can able to see that with my 9 people. Where are the people, guys? Where are the people? Right, so anyway, we are fine people. So this is how you do this one. If you have questions, please ask before I erase. Then we move to the other one. If you have questions, ask before I erase. If you don't have questions, then that's good. Let's continue. I'm gonna erase here, guys. I'm gonna erase this. Right, I'm erasing. If you want to watch it, you can go back, guys. Remember, this is recorded, so you can able to watch it. So those who are not here on the live stream, they can able to watch as well whenever they have a chance tomorrow. Probably other people are studying other subject at the moment, right? I don't know if N5s are writing tomorrow. Are you guys writing tomorrow? Are you guys writing tomorrow? Okay, let's continue. Now we are done with 5.1.3. I hope you guys managed to understood how to do the long division method. Now let's look at number 4.1.4. Let's look at this, guys. Let's look at this. We have the following problem there. We have here it is, guys. Here it is. We have y is equaling to sine x multiply y is equaling to sine 10x multiplied by 7, or multiplied by 7x, sine 7x. Yes, right. So I'm gonna copy this again, and then we gonna do it on the side where we have enough space. All right, so there is a formula that we need to use, guys, when we do this one. So let me copy it very quickly. We have let me just go do it in front of the formula there, right? Formula sheet, because I think you must know which formula sheet to use. So on your formula sheet, guys, you must go to this part here to do this one, right? You must go to this part. Where is it? Where is it? Yes, this is the part. See this part here? I'm gonna zoom it again. The trigonometry part. Yeah, you come here, guys. Remember, what do we have there? Our question, it's sine, I think 10x, right? Multiplied by a sine 7x. There we go. And then all this dx there, guys, right? So look, we have sine multiplied by sine. So look at this here. We have this one here where you have sine A multiplied by sine B. So you can say A is 10x, and then B is 7x. There we go. So you can apply this. You can say this here is equaling to half. Remember, we're gonna use this part here, right? Is equaling to half. Now we have cos. If you can see, we have cos A minus B. So we say our A is 10x minus B, which is 7x. There we go. And then minus, oh, I hope we're gonna have enough space here. We have cos, right, inside the bracket. This time we have A, which is 10x, plus B, which is 7x. There we go, guys. I hope you can able to see this. So we use this formula sheet here, guys, this equation there. So before you integrate, you need to simplify. So let's continue simplify. We still have the half there. Now, if you can look at what we have inside here, we have 10x minus 7x. So we can write cos, what is 10 minus 7? This is going to give us 3x. There we go. Minus, right? And then here inside we have 10x plus 7x. So again, we're going to write cos there. And then what is 10 plus 7? That is going to give us 17x. There we go. And then dx. I forgot to write dx here. Right. So now it's time for us to integrate. You can take out this half on the side. You can say y is equaling to. So we can take the half outside, guys. Right. What is the integral of cos? Remember, when we integrate cos, let me just come here. I'm going to do it on the side. If we integrate cos, for example, we have k, the coefficient of cos, and then we have cos to the power, and then we have cos and x dx. Remember, n is the coefficient of x. Then when you integrate this, it's going to be k sine n divided by n plus c. Remember, when we integrate this coefficient of x, it is dividing there, guys, right? Right, so if you continue here, this is going to give us positive sign. Remember, it's going to be positive sign. And then we're going to have, what is this? 3x divided by 3. There we go. Minus, right? This is going to be positive, or it's going to be minus sign. It was supposed to be positive anyway. So we have 17x divided by 17. And then we have that plus c. Right. Let me just create more space, guys. Let me just create more space so that you can able to see. Right. we do have some. Share the question paper. I will try to share it via the group, guys. I will try to create a link for it, right? But the question paper is 2019 August. Yeah, so if you can look for 2019 August, so Macau, you can go there. Long division, right? When we are finished, okay, I heard there is Truly there who wants me to do the long division method example. I'm gonna do it if we finish on time, guys, right? I have a problem with the mic. My mic doesn't last an hour, guys. It might switch off anytime. So at some point when you don't hear the audio, please comment there so that I can charge it for a few minutes and then we manage to finish. Now let's look at this. We have this half here. So on the numerator, we have 1. So we can multiply everything on the numerator with 1, which is going to be sine 3x, right? But on the denominator, we must multiply this 2 with that 3. This is going to give us 6. There we go. Minus, we have the same sine 17x, and then on the denominator we multiply this 2 with that 17. This is going to give us 34 plus c. Guys, this half, it doesn't affect the c. People, please make sure that you don't get to that point. So here, guys, it's our final answer for this question here. I hope you guys managed to understand it, because I didn't teach this in class. Completely forgot it. If you are in my class, I completely forgot it, guys. I did it when we are doing some revision with the guys that were in class on that day, right? But anyway, just rewatch this again so that you can able to understand. The question was given in this manner: sine 10x multiplied by 7x dx, right? Then we have to use the equation here, the formula here. So you need to go to your formula sheet and use this formula here, right? So we are done with this one, guys. I will have to go and check the other question. So let's check the other question, right? Now, where is it? Macau. This is the question paper, right? It's 30th July 2019. So you can go and download it on the app, and I think you'll find it there. If you can't, then I'll try to share with you. Right, let's look at 5.1. Now, let me just, let's look at 4.1.5, guys. Let me just zoom again, right? Let me just zoom it. Look, we have this one here. This here, it's by parts. It looks very tricky, but trust you me, it is by parts. And then I will try to show you where it was the trick. So let me just zoom down. Hopefully we still have some time for our mic not to shut off on us, guys. This mic has a tendency of shutting off, so I hope it won't, right? So we have the sigma of x divided by sec, right, 3x dx, right? Now this one, it was tricky because you need to apply what we call the reciprocals or the inverses. Remember, guys, that 1 over sec 3x is the inverse of cos 3x. Remember this from N4 metric, we know this. So we need to simplify this first. So if you simplify this, you're going to have x cos 3x dx. You guys see? Now this becomes your by parts. So if you still remember, with by parts we have a list of priority functions. We have the number 1 is supposed to be ln x, number 2 it's supposed to be x to the power of n, number 3 it's supposed to be e to the power of x, and number 4 it's a trigonometric ratio, guys, right? Oh, sorry about that, the alarm. Time for me to sleep, guys. So for the sake of helping you guys, I'm not sleeping today, right? Sleep late today, right? So this is the list, guys. Remember, this list is very important when you integrate by parts. Now this list, you use it to identify which one is going to be your f of x, which one is going to be your g of x prime. Now these ones here, these ones supposed to be the list of f of x, meaning if ln x it's in your equation, it will be the one that is going to be f of x. If x to the power of whatever, 1, 2, or 3, if it's in the equation, it's going to be the one that is going to be f of x, and e to the power of x, and so on and so on. So as you can see, the last one here is trigonometric function. So the formula, if you still remember, the formula for by parts when you integrate, I think is like this: is dy, and then you have f of x. Okay, before we do that, the formula f of x is like, I mean, our by parts is like this: you have f of x, right, and then you have g of x prime, guys, right? I'm not gonna use the substitution method. I don't think, for me, it's too confusing, guys. So I hope this method is going to help you. It's f of x and g of x prime. So what you do here, you differentiate f of x, you integrate g of x prime, right? That's what you do. So the first step here, you rewrite f of x as it is. So you're going to rewrite f of x as it is, and then you integrate g of x. Remember, when it does not have prime, it means it's been integrated. Then you say minus, right? And then the second term, you differentiate f of x, and then you leave g of x inside the sigma, and then dx, right? So this is actually the formula. So you have to choose which one is going to be your f of x here, which one is going to be your g of x. By looking at our priority list, this list here, our f of x here is going to be this here. It's going to be x. And then our g of x prime is going to be cos. So from there, we need to apply this formula. So let me just create the space there. Are we still together, people? Are we still together? I hope we are still together. Like, really, I hope we are. So let me continue here underneath so that we can able to solve. So when you integrate, oh, where is it? Yes, when you integrate, guys, when you integrate, so this is going to be like this. You're going to have to rewrite f of x as it is. So remember, f of x is x then, and then we integrate g of x, right? So what is the integral of g of x prime, by the way? So I'm going to do it here. Again, guys, when you integrate, you're going to have k cos n x, then the integral there is going to be k. Remember, cos is going to be positive sign, the integral, n x divided by n, right? So our n here, it's 3. Do you guys see? So you're just going to apply that. So our k, it's 1. So even if you don't write it, just going to write it as a sine, right? 3x divided by 3. There we go. Minus. So this is our g of x. Now, look at this equation here. We must derive f of x. But what is our f of x? Remember, our f of x is x there. So what is the derivative of x, guys? So what is the derivative of x? If you are given x there, and then you have to derive it. What is the derivative of x, guys? It's 1. So this is going to be 1 multiplied by your g of x, this one that you just integrated, which is that one there. So you're going to multiply by sine 3x divided by 3, right? So all this dx, let's not forget dx here, right? Let's continue. Now you have to take out the, what is this, the common factor, oh, not the common factor, the coefficient there, right? Our coefficient on the second term. So let me just do it. If I rewrite this, this is going to be x multiplied by sine 3x divided by 3, right? Then we take out the coefficient here. We have 1 on top there, and then we have 3 underneath, this 3 there, right? And then inside there, we actually left with sine 3x, right? dx. There we go. So we continue. Now the first term is fine, guys. It's already integrated. So we have sine there, 3x divided by 3, and then we say minus 1 over 3. What is the integral of sine 3x? Again, let me just show you guys. Let me erase this very quickly. Let me show you this very quickly. The integral of sine, you'll be given this, right? You have k sine, right, and x, right, dx. So when you integrate this, this is going to give you negative, let's say it's going to give you k, but the integral of sine is negative cos, right? N x divided by n. Let us not forget the n, guys. This n, most people tend to forget it. So I'm gonna do it here. So we're gonna have negative, right? Our k is 1 over 3. We are fine. So we're gonna have negative cos 3n divided by our n there. You can see, or 3x, I mean. So divide by our 3 plus c. So this is our final answer. So to make it look neat, we have to multiply the negatives. So the first term still okay, guys, is still okay. Divide by 3, and then minus and minus, that is gonna give us positive. So we're gonna have positive, and then on the numerator we have 1 multiplied by everything that is there, which is gonna be cos 3x. But on the denominator we have 3 multiplied by 3, and that is gonna give us 9 plus c. Are we still together, people? This is by parts. I hope it's not the by parts that you were asking about, Masugu. Masugu, is this the bypass you were asking about, or is something else? Right, let me just zoom down, guys. Right, so this is what we have. This is what we have, guys. If you have questions, ask questions, people. Ask questions on the comment section there. If you don't, then it means that you guys understand. I will move on. Right, so this was the by parts. The tricky question here, or the tricky part, was 1 over sec 3x. So you're supposed to change that into cos 3x. Then you'll be doing by parts. And also, don't forget this list here of priority functions there. Remember, the first one should be the one that have f of x. So it's ln or x to the power of n or e to the power of x or trigonometric ratio, right? All right, so I'm gonna erase this, and then we're gonna do the last question. I think we'll be doing the last question. Then from there, hopefully, if we still have the power on our mic, we'll be able to do other problems that you guys have questions on, right? Okay, right. So let's continue. Let's continue. Let me just zoom this very quickly. I hope our battery won't die on us, guys. The battery tend to die. This one here, guys, we have 4.2. This one is way tricky, guys. I really hope that you guys you are paying attention. I really hope you are paying attention. Masugu, if you say it's a question from textbook, what activity and what question? Can you check for me? When I'm done with this, maybe you're gonna check that one out. Right. Can you check me for me the number and also the what is this? And also the activity, right? The number of the question and also the number of the activity. So we're gonna do this one, guys. 4.2. They want us to obviously integrate using partial fractions. Guys, this one, it's so tricky. That's why they put this star thing there. I hope you'll be paying attention, right? If you are not, leave whatever you're doing and pay attention. So let me just zoom out, and then let me write it on the side, because I don't remember doing this in class. You know, we did the obvious ones, but this one here, it's a bit tricky. But the trick is not that much of a trick, guys, right? It's not that much of a trick. All right, so we have that dx, right? So let me just create space so that you can able to solve it, guys. Right, I'm gonna put it here. All right, so let's continue. Let's continue. I hope we have enough. I hope we have enough space, people. I hope we have enough space. All right, people. So this one, first of all, here, guys. First of all, when you use by parts, I mean, when you use the partial fraction, guys, remember your denominator and the numerator should not have the powers that are equal to each other. Or let me just put it this way. Your numerator here, as you can see, we have x to the power of 2. It has the power of 2, and your denominator has the power of 2. So if the powers of the x are equal and the one of x squared here on the numerator is greater, we're supposed to use the long division method. Remember the long division? I said, how do you recognize it? When the numerator have the highest power. Even if when the numerator has the power which is equaling to the power of the denominator then, right? So make sure, guys, that before you use this partial, you need to divide this using the long division method again. But this one is simple because it's only x to the power of 2. So that's how you're supposed to do it. So the trick here was to divide this first. So Trudy, I hope you're paying attention, but I'm not going to show all the steps because this is too short. So you have the divider there, our divider, which is x squared minus 1, right? And then what are we dividing? We are dividing x squared, right? So simple. First step, you divide this x squared with that, right? So what you do is this x squared, this one here, is going to be divided by that x squared. So what is our answer there? The answer is going to be 1. Write it on top there. And then from there, the second step, what do? You multiply all these by this one, right? So let's multiply them. So if you multiply x squared, if you multiply x squared with 1, you're going to have x squared. If you multiply this negative 1 with 1, you're going to have negative 1. There we go. I hope truly you are paying attention here. This is just a glimpse of the long division method, by the way, right? And then from there, the second step, oh, this is multiply, by the way, multi. The third step is we multiply by negative 1. So these ones here that we just got from multiplication, we multiply by negative 1. There we go. So if you multiply by negative 1, this negative 1 multiplied by x squared is going to give us negative x squared. And then that is going to give us positive 1. So the fourth step, we add or subtract. Okay. So we add or subtract. So this x squared here, this x squared there, it's gonna be negative, and then it's gonna subtract with that one there. So they're gonna give us 0. And then what is it that we'll be left with? We have this negative 1 multiplied by that negative 1. They're gonna give us positive 1. So that is our remainder. That's it. So when you rewrite this, my good people, when you rewrite this is gonna be as follow. I hope you're gonna be able to understand. So you have to rewrite this like that. So it's gonna be 1, remember this one here, and then plus 1, remember our remainder here, divide by x squared minus 1, and then all this dx. Oh, I hope you guys can able to see this. Really, this is where the trick was. Then from there, we can separate them. I can say to you, do the following. I can say to you, write them like this. Okay, sigma 1 plus sigma 1, and then we have x squared minus 1, and then dx. Right, all of them obviously is dx. There we go. Separate them. This one, we're going to deal with it later. This one, that's where we need to use partial, guys. This one here, we need to use partial. So I'm going to do it here. So let me continue, do it here on top. We can say, right, 1, and then we can say, look, our numerator here is the difference of 2 squares. So we can say x minus 1, x plus 1. There we go. Our mic is still fine, guys. So yeah, I hope it won't switch off. So let's continue. So we have a divide by, we're going to choose the first one, which is x minus 1 plus b, and then it's going to be x plus 1. There we go. Remember, we have to multiply by our numerator for both sides. So if you multiply by our numerator on the left hand side, we're still going to have the sigma of 1, right? Okay, let me just let's leave the sigma. We're gonna be left with 1 there on the right hand side, on the left hand side, and then this side here, this is gonna divide by that. So we're gonna multiply a with x plus 1. There we go. I hope you guys can see. So it's gonna be a multiplied by x plus 1. And then let's go to the second one. And then this x plus 1 is going to divide with that x plus 1. So we're going to be multiplying this b with x minus 1. So let's write it there. So we're going to have b multiplied by x minus 1. There we go. Now, when it's like this, we start seeking for a and b. So first, we look when we have x as our reference. So any number that has x, we must write it there. So on the left hand side there, we don't have x, so we can say it's 0, right? And then equaling to. So if you can look at a multiplied by x is going to be ax. So we're going to take only the coefficient of x, which is a in this case. Now let's look at b. If we say b multiplied by x, it's going to be bx. So the coefficient of x in this one is going to be b. So it's going to be plus b. And then we can say b, let's just continue, or a, let's just say b. You can say b is equaling to negative a. This is equation 1, right? Now, let's use constant as our coefficient. So if constant is our coefficient, meaning if we have just a number there, okay, if we just have a number just like this one here, the constant here is 1. So we're gonna write 1. You guys see, right? Now, equaling sign, we don't have any other constant. Now we can say a multiplied by 1, that is gonna give us a. You guys see? And then on this one here, we have b multiplied by negative 1, that is gonna give us negative b. Therefore, we can say that a is equaling to b. There we go. I hope everything is fine, people. I hope you guys can see. Hope you can see, because this was one of the trickiest question ever. If you don't know this one, you might find yourself confused on how to do it. So we can say this is equation 2. Let's look at these two equations here. We have to substitute one of the equation into the other. You can just say substitute sub 1 into 2, right? That's it. So if you substitute 1 into 2, it means wherever there is b, you're gonna put negative. Oh guys, oh, I made a mistake here. Oh, you guys don't comment at all. We made a mistake here. We have 1 there, guys, right? Equation 2. Oh, we made a mistake. We have this one here. I almost forgot about this one. So this is actually, when you transpose there, it's gonna be b plus 1. There we go, guys. Oh, we made a mistake. Don't forget the 1 there. I almost forgot it. But anyway, it's fine. So if we substitute 1 into 2, oh, this is our 2 now. If we substitute 1 into 2, wherever there is b, we can put negative a. So we can say a is equaling to negative a plus 1. So we transpose this, we're going to have 2 a's, and then this is equaling to 1. Now, let me create a little bit of space there. Guys, you are so quiet in this group. You divide by 2 throughout, so a is equaling to half. There we go. And if a is equaling to half, then this means that our b is going to be equaling to negative a from this equation here. You can see b is equaling to negative a, so b is equaling to negative half. There we go. There we go, people. I hope you managed to see this. Really, if you did not, you can always rewatch it over and over again. Now we go back to our original equation, guys. Let's go back to our original. Ooh, hopefully we're gonna be able to do it. So remember, here we had the following, right? We know that we're gonna have, if I still remember, if I check there, let me just do it here, guys, right? If I check here, we said sigma, it was it was a, let me just redo it, a, and then x minus 1, right? Or let me just redo it like this, everything. Let me just do everything now. We have 1, remember this one here, there we go, and then plus, then we have a minus, I will divide by x minus 1 plus b divided by x plus 1, right? then we have dx there, right? Let us not forget this one here that we got earlier when we do some division. So we know that our a, it was actually a half, so you can write it as 1 over 2 multiplied by x minus 1. There we go. And then this one, we know that b was minus half, so it's gonna be half 1 over 2 multiplied by x plus 1. Let me see if we did the right thing there, guys. Let me double check. Because I don't remember very well. Oh, our b was, yes, we are correct. So our b is minus half. There we go, guys. There we go. I hope you guys are fine, people. I hope you people are fine. Are you still coping? Do you still see? So when we integrate them, this one is a constant. Remember, when you integrate the constant, this is going to give us x. Now, these two here is type 2. Remember, type 2, it states that when you have f of x prime divided by f of x, your integral is going to be y ln f of x plus c, right? So everything is fine here, guys. So all you have to do there is take out these coefficients. First of all, the half, take them out. Even this one, the negative half there, you take them out first, right? And then you integrate it. So this is gonna be a half ln, right, x minus 1, there we go, minus half ln x plus 1 plus c. So this here, guys, is our final answer. There we go. I hope you guys managed to understand this, and I hope you didn't get lost anyway. So this is one of the question that was a bit tricky when it comes to partial. So whenever you are given this type of a question, do not despair, guys. Make sure that you know exactly what to do, because this one here, we had the numerator with the highest power, with the power that is equaling to the denominator. So when this happens, basically it means that you should use some long division method on the all the other method, guys, that you know of. Because of this, we have 2 there, we had 2 there, so we couldn't just jump straight to partial. We had to divide first. So after dividing, we'll be having 1 plus 1 over x squared minus 1. Then from there, this part here, we do it there, we get our a, is our a, and we get our b. And then from there, we substitute here on this part, and then we get our final answer. I hope you guys can see. I just zoomed down so that people can see this. We are done with this question. By the way, it has 24 marks. It had 24 marks, guys. And then yeah, that was it, guys. It has only 24 marks. All right, so now, do you guys have any questions before we look at that question of Maslugu? I have to look for the book. I don't know where the book is. Page 133. Okay. Page 133. Let's look at it. Page 133. 133. Page 133. Activity 4.6. What number is the question? Number 3. Oh, number 3. Okay, let's try it. Masugu, let's try it. Number 3. Oh, looks, it's a partial fraction. Oh, all right, it's a partial integral. So, Masugu, are you there? Think. Nokutula, Masugu, are you there? We're about to solve your problem. So, this is Nokutula's problem, guys. I think we did something of this sort in class, right? You just erase this very quickly, guys, right? Let me erase this very quickly, but I think we did something of this sort in class, right? But anyway, let's just do it. This will need space, guys. It will need enough space for us to do it, guys. If you guys don't have questions, then it's fine. Let me just do Noctula's problem. So Noctula's problem is as follow. We have to integrate the following. We have x to the power. Let me just go straight at the corner. We have x to the power of 3, and then we have cos, then we have pi x, and then we have dx, like that, right? Is this the question, Noctula? Yes, yes, yes. I hope you can see this is your question. So I'm just gonna inform you guys. So remember, the formula goes like this: you have f of x, right, multiplied by g of x prime, right? So when you integrate here, right, it's gonna be f of x multiplied by g of x. Oh, not g of x prime, by the way. G of x minus, right, f of x prime. There we go. Multiplied by g of x, right? But now this one, because it has x to the power of 3, it go further. But for now, this is the basic. Now remember the list. Remember the list. It goes like this. The priority list, we have All right, I think I've charged the mic. I don't know how long it's gonna last. So let's continue. So you have this list here, guys, that I just showed you here. Let me just highlight. So this list here, it shows the functions that you must prioritize as f of x. As you can see, we have x to the power of 3 there, which falls to number 2, while trig falls to the last one. So meaning f of x is gonna be our x to the power of 3 there. So when you integrate this one, guys, let me try to do it here. Let me highlight them. When you integrate this, remember the first step here, which is this one here, right? You will write f of x as it is. We have x to the power of 3, right? And then we have to integrate this g of x prime, which is cos. So what is the integral of cos pi? So we know that the integral of cos is going to be sine, right, pi x, but divide by pi. There we go. Then we say minus. So this minus here, rather put it inside the bracket like that. Now, remember, the second step, what do we do there? We differentiate f of x. So what is our f of x here? Our f of x is going to be 3. Oh, this is too long. 3x squared multiplied by the integral of that one here, which is sine pi x divided by pi. There we go. Let's just put it here for now, and then let's continue. I'm gonna do it step by step, no tula. I hope you will be fine, because this one we have to be very, very careful, guys. We have to be very, very, very careful. There we go. Now I'm still gonna do this. Take out the the coefficient here. Oh, let me not. So if we continue with this one here, this is gonna be 3x squared, right? What is the integral of cos? So we know that it's gonna be negative, right, of sine. I mean, the integral of sine is gonna be negative cos, yes. And then what do we have there? We have pi, right, x, and then divide by pi. We have pi there, so this is gonna be pi squared, because when we integrate this, it's gonna be remember, let me do it here. We have 1 over pi outside there. You can see. So it's the same as we have this, right? There, right? So the integral of sine is going to be 1 over pi, then multiplied by cos pi x divided by pi. So let us not forget it's gonna be minus. So this pi and that pi, they're gonna give you the pi squared there. I hope you can see that, Noctula. So let's continue. So if we continue, this is gonna, oh, by the way, we still have this here, guys. Still have that bracket there. Let us not forget, right? So if you continue, this here is gonna be, just do this, we're gonna say minus again. So what do we minus here? This here we're gonna minus it with our integral. Remember, we differentiate our f of x. This time around we're gonna have x to the power, we have 6x, right? Let me create some space there, guys. Let me create some space. Oh, I'll have to move these as well. Let me just move this very quickly. I hope they're gonna be moved. These are formula sheets, by the way, guys. That's why I'm moving them. Right, Noctula is still there. Are you still there, Noctula? Because you asked this difficult question, man. Right, so we have this, right? And then we're gonna have we're gonna take all this here. Can I write here to the power of 2? So we can say negative, the integral of negative, what is it, integral of negative cos I x. There we go, right? So we can take out, oh, by the way, this is still on the same, there we go. So this is still on the same uh This is still on the same bracket there. So let's continue. So we're gonna have this x cubed multiplied by sine x divided by x, right? Then let's do the brackets. Oof, we have minus there, minus. Then let's do the bracket. There's the bracket. So this one here is gonna be negative. Can I write it as negative? Remember this negative here? I'm gonna write it there as negative 3x squared cos pi x divided by x squared, right? Then let's integrate this one now. If we integrate these, then what is the integral of negative cos? It's going to be negative sine multiplied by the negative there. So that is going to be, remember, the integral of this negative cos is going to be negative sine multiplied by this negative there. So this is going to give us plus, right? Let us not forget the coefficient. We have x, right? And then divide by, remember when we integrate this, we're gonna divide by the pi. This pi here that we divide with is gonna multiply with these ones here, so we're gonna have pi to the power of 3. There we go. And then we continue and we write the integral there, which is gonna be cos, right? Cos pi x minus, again we continue here, we're gonna have the integral or the differentiation of f of x. Remember, our f of x is being this here, guys, right? This is our f of x. So we have to differentiate it. So when you differentiate it, it's going to give us 6, right? And then we have the following. This time around is going to be 3. There we go. And we're going to write our f of x there, which this time around is sine, and then pi x, right? And then all this on the same bracket, Noctula. Your question, Noctula, I don't like it, man. It makes me think too much. But anyway, let's just do it. Let's just do it. Let's just do it. So we continue there. Let's see. Let's see. Right. So y is equaling to, now we work it out. So we're gonna have x to the power of 3 sine pi x divided by pi. And then we still have this inside the brackets. Let me just continue with our brackets there. We have negative 3x squared cos pi x divided by pi squared plus 6x sine pi x divided by pi to the power of 3. This time around we integrate this one there. So obviously we're gonna take out the these ones here, the coefficients. These are the coefficients in Octula, but we're gonna take them out. But even if we don't, we just integrate sine them. So what is the integral of sine? It's gonna be negative cos, but we do have negative there. So this is gonna give us positive 6, right? Cos, and then we have pi x, and then we divide by x to pi to the power of 4. Then all this, yeah, is still on the same negative path. I hope this is correct, guys. But there is a way of checking it, right? Then we divide by that. All right, so let's continue. I think this is the final answer, guys. You can't integrate anymore, right? So let's continue. So this here we can say y is equaling to x cubed sine pi x divided by pi plus, remember we multiply by negative, so this becomes plus. It's gonna be plus x cubed squared cos. Are we still together, Noctula? Oh, okay. Let me continue. We have pi x. I was reading the comments, by the way. That's why I went quiet. And then minus, I think we're gonna have minus there. think we were supposed to have plus there, but anyway, let's see. X sine pi x divided by pi to the power of 3 minus again 6 cos pi x divided by to the power of 4 plus c. I think this is your answer, Noctula. Can we double check? Let me double check it here on the book. I hope this is the correct answer. It's activity 4.6. Oh, very interesting. If it's not correct, I'll find a way of doing it. But there is a way of doing it which is shorter, but I wouldn't recommend it to anyone. 4.6. Where is 4.6? Oh, guys. Is it correct? Is it not correct? Let's see. 4.6. Are we still there, people? 4.6. Oh, yeah, there we go. Okay, we have it is not correct, people. These people they have ooh No, all right, my mic was off, guys. So I'm using this method, which is the one of the shorter method. So what you have to do here, your f of x, remember, is this, and then your g of x prime is that. So what you do here is you derive your f of x until it gives you 0. So if you can see here, we derived it until it gives us 0. I think the fourth derivative, it gives us 0, right? And then what you do after deriving it, you must put the signs, which is plus or minus, plus or minus. The alternative, start with plus, minus, plus, minus, plus, minus. And then here, your g of x, you keep on integrating it. So this one here is your g of x prime, obviously. Keep on integrating it until it aligns with this. So from there, you multiply these, right? You multiply them, multiply them, you multiply them. There we go. So if I multiply them, let me just create space there, right? Let me see if this is gonna give us our answer. So if you multiply this one and that, you're gonna have x to the power of 3 sine pi x divided by pi. There we go. So if you multiply that with this, we have negative and negative. That is gonna be positive. So you're gonna have positive 3x squared multiplied by cos pi x divided by pi squared. There we go. Now if you multiply this one with that one, by the way, with this one, we have negative here, so this is supposed to be minus. So this is supposed to be minus. What is our answer? Minus 6x sine. Wait, let me create more space. I hope you can see Noctula. 6 sine pi x divided by pi to the power of 3. And then we multiply this one here with that one. We have minus there. So this is also going to be minus. It's going to be minus 6, minus 6. And then we have cos pi x divided by pi to the power of 4 plus c. Noctula, do you see? It's the same, man. Do you see our answer? Is the same. I don't know what's happening there, but it is the same. So I will check your answers on your book, but that is the correct answer, my good people. Nugutula. Because let's look, if you can go to the book and check the memo, look at the first term. Does the first term correlate even with the question there? Because remember, we have x to the power of 3, right? We have x to the power of 3. So where is the 3 there? Where is x to the power of 3 for the first term, right? And in the second term we have 2, right? So where I think they divided by 3 throughout. They divided by 3 throughout on the question, and also they only did okay, I don't think it's correct, Nuktula. I don't think the integral of that question of yours is correct, right? double check it double check it. And also if you have some AI, what is it, some AI app, try to use it there. But I don't think it's correct. I think ours here, because I use two methods to check, they give me the same answer. I think ours it's correct, but double check it as well, guys. I think we are done here with um with our integration. Don't I think you shouldn't pay attention to the last question that Noctula gave us. It's above, I think it's beyond your syllabus, guys, right? But if you want to learn it, this is how you do it. I've shown you two ways of doing it, guys. The other way is a shorter method. I'm not so sure whether they're gonna mark it or not. So yeah, but the first one, it's correct, guys. We are done. Are you guys keen to do another live stream on other topics that we're gonna that we're gonna be writing about? Are you keen, people? A yes will be appreciated. If you guys are not keen, it means this is our last stream for N5. Are you guys willing to do the next stream for question, I think question 2, the derivatives? Are you keen to do the derivatives? Yes, we'll appreciate it. Even if there's 9 of you guys, if you say yes, if you say no, we are fine. We will study on our own. Then I'm only gonna focus with enforce, because enforce, they seem to watch this, right? And my mic, it's bad, guys. My mic is bad. Sometimes it switches off. I'm having the very same problem with enforce. After an hour, it switches off, and well, because enforce, they really want to learn. They stick around until I charge it enough for me to able to help out, right? 3 people are saying yes. What about others? Tomorrow, are you guys writing? Because I'm gonna have a live stream with the N4s at 4:30, meaning you guys, I can have the live stream with you around about these times, guys, around about 7, 7:30, because I really need to rest after the live stream. So 3 people, it seems like it's not gonna happen, people. It's fine. The time when you guys will want to do the live stream, you will let me know, because I saw on the group there asking about the live stream. A lot of people said yes, about 40 people. That's why I've done it. So only 9 attended, right? So okay, yes, the fourth one, Tao, right? Who else? We're waiting, people. We're waiting. If you can be more than, because there's 9 of you in this stream, can be more than 5. 5 is too little, man. If you can be more than 6, right, who says yes, then we're gonna do the live stream. If you're not, then you guys, it means you are fine. You don't need the live stream. You'll be able to do this, right? But anyway, so this is how you solve that questions, those questions, people. N5 is quite tricky, people, right? It's quite tricky, and we are have to use the N4 information here, people. We have to use the N4 information. All right, people, we are done. It means no live stream for N5 tomorrow. Good luck with your test, guys. You'll be writing on Wednesday. The what is this? The timetable has changed, so you guys, you're writing on Wednesday, as you can see from your payments there, guys, right? Thank you for watching, people. Till next time, we are out. Remember, if you're not in a WhatsApp channel, you can scan this and then be part of our channel. All right, people, let's end the stream.